On to Geotech homework problem number 8. Here we've got a 10-foot clay layer, and I went ahead and drew that here, that's sandwiched between two free draining granular soil layers, so that double drainage during consolidation can occur. So that means it's pervious at the top and pervious at the bottom. So if you've got water, its shortest path would be just half that thickness. It doesn't have to travel the whole thickness to get out. So remember, that's going to affect your HDR value. All right, calculations indicate that the effect of a planned building will be an ultimate settlement of 2 inches as a result of the clay layer's compression. The coefficient of consolidation for the clay is 0.1 feet squared per day. So I'm just going to go ahead and write some of this information down before I go ahead into solving it. So I already talked about that my drainage height here is going to be the thickness of the clay layer divided by 2, because the shortest path for any water is going to be getting halfway through there. Okay, at any point, or sorry, the longest path would just be to do halfway through that height. Okay, it's always going to be that or less to escape from there. So in this case, that's just 10 feet divided by 2. So my HDR here is going to be 5 feet. I was told that the settlement due to consolidation is 2 inches. A coefficient of consolidation for the clay, and this is that one that has feet squared per day, so that's indicated like this with the CV. And you can tell it's that because it's got units. Remember, the CC does not have units, so that's 0.01 feet squared per day. Okay, I think that's all the information we know from the start, so let's go on to part A. How long will it take for 90% of the estimated settlement to take place? All right, so we know that our U is going to be 90%. So our first thing we're going to want to know is, what is our T? Whenever we have that percent of consolidation, think, okay, I can figure out my T, because you've either got your graph here that you could use and say, okay, 90%, and come along here and kind of try to read a value here, which is a little tricky to do. So I recommend you go ahead and take the shortcut and use the table here. You'll get a much nicer value. So at 90%, my T is 0.848. I'll just go ahead and use that to 3 digits, but usually 2 digits is fine. So my T is 0.848. And then I'm going to go ahead and use my formula, which is also at the bottom of this page. And I'll go ahead and write that here. That T is equal to that coefficient of consolidation, CV, times little t over my HDR squared. But remember, in this case, I'm looking for how long it will take. So I'm really looking for this little t. So I know the big T, I know the CV, and I know the HDR. You can solve that algebraically, or you can start just plug numbers right in. Kind of up to you. I'm going to go ahead and solve it algebraically. So I'm going to go ahead and multiply both sides by that HDR squared. So I wind up with T times HDR squared is equal to CV times my little t. And then I'm going to divide both sides by the CV. And those will cancel out. And so I wind up with little t is equal to big T, that time factor, times the drainage height squared divided by that coefficient. So now I'm going to go ahead and plug some of those values in that I know. So I said my big T was 0.848. My HDR in this case was 5 feet, because I just needed to go half the distance. And my CV here was 0.01 feet squared per day. And that's going to equal T. So let's go ahead and put that in. I can already see my feet squared are going to cancel out here. I'm going to wind up with per day in the denominator of the denominator, which hopefully by now you're recognizing that that would just go into the numerator. So my answer is going to be in days. All right, so it's 0.848 times 5 squared, I know that's 25, and then divide that by 0.01. And I get 2120 days. So that's a good long time there. If I want to, I could put that into years just to make it look a little bit more sensical, so divide by 365, and that would be 5.8 years. So it's going to take a while for that soil to get to that 90% consolidation. All right, let's go ahead on to part B. How much settlement will occur in 1 year? So that's how much is going to occur in almost 6 years. How much is going to occur in 1 year? So that's going to be my part B. So now I know that my T is going to equal 1 year. But because this CV value is in per day, I'm going to transfer this to days so I have the same units. So the 1 year is 365 days. If I want to use that information, I can then go ahead and solve for the capital T. So in this case, I can use this original equation here, that my T is equal to CVT over HDR squared. And so now I can just plug my values in, 0.01 feet squared per day times 365 days, all divided by, my HDR, remember, is 5 feet squared. And when I put that into my calculator, I get 0.01 times 365 divided by 25. Get something kind of small, 0.146 for my T. And so when I look onto my chart here, well, that's right around a U of 43%. So it's 0.145, I got 0.146, but that'll work. So my percent of consolidation that I've gotten is 43% at that 1 year mark. Remember, we saw that, so it's 43% in 1 year, and to get all the way to 90% is going to take it another almost 5 years. So that's kind of interesting to think about, and that makes sense when you think about how consolidation of clay works. And then we want to actually know how much settlement is going to occur. So not just the percent, but let's get a value for that too. So I know also from this equation that U is equal to that settlement over whatever time we're looking to over the total settlement. So U is SC, and I've already been told that SC is 2 inches. So I'm going to go ahead and solve for this ST. If I multiply both sides by SC, I get U times SC equals ST. I just found that U is 43%. I'm going to put that in as a decimal. 0.43 times my 2 inches. And that's going to be my settlement over time, which in this case is 1 year. So I'll put that into my calculator. I'll get my ST. It is 0.43 times 2, and it's 0.86. Remember, this is inches here because I'm putting inches in. So, we could say that's about 0.9 inches. Round that up a little bit. All right, so it's in 1 year, it's 43% consolidated, and it's about 0.9 inches. And then last part of this problem, how long will it take for 1 inch of settlement to take place? Okay, we're pretty close to 1 inch of settlement, but we're only at 0.9, so it's going to take a little bit more than a year. So let's go ahead and put this in. So now, instead of knowing the T and U, we're going to say that our ST is equal to this 1 inch, and our SC is equal to the 2 inches. So my U in this case is just 1 divided by 2, which is 0.5. All right, so we're looking at a 50% consolidation for this case where we have 1 inch that occurs. And so I'm going to have to find my t value here. Go to my chart. So for 50%, I have the value of 0.197. So my t is equal to 0.197. And remember here I wanted to find the amount of time. So I'm going to solve for my little t. I'm just going to go ahead and use what I had found before, that little t is equal to big T times that drainage height squared, all divided by coefficient of consolidation. So in this case my big T is 0.197. My HDR is still 5 feet squared over my 0.01 feet squared per day. And you can see I'm going to get my answer in days here. So let's go ahead and put that into the calculator. 0.197 times 25, and we'll divide it by 0.01. And that gives us 492.5 days, which, just as we predicted, is going to be greater than a year, because remember we found that in a year we only got that 43% consolidation, which was only 0.9 inches. We want to get to 1 inch consolidation, which is about 50% of it. So it's going to be 492.5 days. Let's see how much over a year that is. So I'll just divide that by 365. That's like 1.3 years. So a little over a year to get to that 1 inch of settlement, or 50% consolidation.